In this video, we are going to extend our knowledge of vectors, talking about what is called a unit vector. All right, so a lot of times in our applications in math, we like to find a vector that lines up with another vector, or just really we want to describe a direction. Maybe not a force or velocity, but we just want a direction. The best way to do that is to have a vector, but make sure the length is 1. The reason we do that, because it has a length of 1, that's great, cool. That doesn't really have, the magnitude is 1, but it doesn't really describe a force unless the force is 1. But it makes it a nice, easy vector to describe direction. So we can make any vector, and we're going to want to do this with a lot of theorems that are coming up are going to require a unit vector, not just a vector. Okay, so a unit vector, how we find that is we find the magnitude of the vector and divide by it. We're going to do this a whole lot, so we'll get used to this idea. Okay, so let's do an example because it's best to see it there. I have V is negative 4, 7. They want us to verify the length is 1. All right, so find a unit vector, so we're going to have to do that and then verify. So the magnitude, this is our first thing, because if it is a unit vector, we can just leave it. All right, this is equal to the square root of 16 plus 49. All right, that is 65, the square root of 65. All right, let me scoot this over and rewrite that. I don't know, I started so far to the right. Square root of 65. So if I want to find a unit vector, okay, and then I'm going to actually go ahead and introduce this. If I wanted to make a unit vector, we actually have a new symbol for that. It's a hat. So like arrow above it. This means unit vector. So unit vector, I just do 1 over the magnitude, and I times it by the original vector. Now, a lot of times in my course, you're going to be able to just multiply it through and stop. I don't know about your Calc 1 and 2 professors. I'm having trouble with this brace here, bracket. If they made you rationalize, I don't make you rationalize. That I think is an out-of-date thing. I think it's useful in some contexts, but you guys have seen it to the point where you got the usefulness in the algebra portion, meaning like when we solve a rational equation as a square root in the denominator with variables, then yeah, rationalizing makes sense. But rationalizing just a number, it's a bit out of date. I won't go on the path. It has something to do with slide rules, if you've heard of those, but we'll leave it there. So that is my new vector. They also want us to verify that this vector is 1. The length is 1. So I'm going to go ahead and plug all that in. All right, so if I multiply that out, okay, I got 16 over 65 plus 49 over 65. You can kind of see why the theorem is the way it is because now I'm going to get a 1 underneath, which is 1. Dividing by that square root of the square of the sums actually just matches the numerator in this case, forcing a unit vector. Okay, so that's how you find a unit vector, and that's how you verify, right? Magnitude finds length. These are going to be helpful for describing a direction without a magnitude. Okay, one more idea here, the triangle inequality. I like to think about this in, take a side. Okay, so here's one side, and I'm going to connect it. Let me do a line here because I'm gonna need the line. So here's one side. And then I'm going to do another side here, right at the same point. That's going to be longer. Okay, so what I'm thinking about is connecting the 2 points of those lines to create a triangle, right? Just like this. I'm going to draw it in here, but I got to erase it because I'm going to move things around. From this point to this point, creating a straight line, I get a triangle. Now, I can move that pink line around. That's what I'm going to do here. I could imagine it stays the same side, okay? Then the length that we get for the hypotenuse, we're going to look at a max and a min. All right, notice that if I move this pink vector, hold on, down a little bit, that the length of the side here gets longer, right? If the pink one moves out, that black side is going to get longer and longer and longer. But if I keep going down, I'm going to eventually get a straight line across, and I can't make a triangle. So the closest I can get is, okay, let's just bring it down to where it's almost there. And then if I do a black line from this point to that point, I get a very small triangle, but you can see that the triangle's still there until the pink line reaches the flat. So the max is going to be u plus v, right? If this is u, and let's call them here, these are links, right? And v, the max is u plus v. Remember, we don't write just u and v like this because that's a vector. I'm talking about the length. The length is a magnitude. So the max there is the sum of the two. The min, okay, let's start talking about this. I can take this pink line now, and I can rotate it the other way, and notice that it gets really close like here, and the smallest it's going to be, oops, I moved it, is going to be almost the, let's try to get this right, there we go. It's going to be the the magnitude of v minus the magnitude of u. I can either have the pink and the blue line extend all the way out to get max, or go all the way down. So we actually did more to this inequality. We know that it also is no shorter than the length, or the difference. Okay, this thing, for you mathematicians that are going forward, this thing is going to be used a whole lot, the triangle inequality. It's going to save you out of some sticky parts and some proofs. But this is where this inequality comes from. All they're saying is, this is the black line over here. That black line has to be less than the sum, right? And we just talked about that, because if I move this pink side out, so I can do it, yeah, move it out like that, it can't get past adding them together because we no longer have a triangle. It would just be a straight line. So the length has to be less than the sum of the two. Like I said, this is going to be used for you guys that are going to be in theory heavy stuff. Otherwise, I can't speak for a lot of applications. I haven't seen it in too many of applications. That last statement makes sense, that if I have equality, they go in the same direction. Okay, so that is a unit vector, and then also the triangle inequality.